Hey guys, so today we'll talk about the Poisson distribution, and don't worry if it's been confusing to you in the past, it's actually pretty simple. We'll make some good examples and by the end of the video everything will make sense. So the Poisson distribution is defined as the probability of big X equals little x, and we'll get into that in a minute, equals lambda to the power of x e to the minus lambda over x factorial. Now, what is this whole mess? Now, big X is a discrete independent variable. We talked about independent probability in this video here. But when it's equal to little x is what we're interested in. It's the number of times something happens in a given interval of time, or an area, or just some space, some area. Lambda here is the mean, right? Usually you see it written as mu, but in this case we say it's lambda, so it's the mean, right? E is, of course, Euler's number, and you can check that out in the previous video. It's to the power of negative lambda, so it's the same number, and x factorial. And factorial, of course, is, what is an x factorial? It's defined as x times x minus 1 times x minus 2, so on and so forth, times 3 times 2 times 1, right? So you know what a factorial is. So this can be used to find the probability of something happening a discrete number of times, right? So it's like 1, 2, 3, whole number of times, if we know the average of this thing happening, right? So this is an example of something like, how many visitors per day does a fast food restaurant receive? Or how many car accidents happen in a day? Or how many flowers on a plant? So if we know like the average number of flowers on a plant, what's the probability of some other number of flowers being on that plant, right? This is what the Poisson distribution is for. Now let's take a look at the first example with the average of being, let's say, lambda equals 2 croissants for the Poisson distribution. Croissants. So let's say you eat on average 2 croissants per day, right? And we want to know, what is the probability of you eating 10 croissants in a day, right? If you're eating 2 on average, what are the chances that you're going to eat 10? You're going to wake up on a Thursday morning and just binge on croissants. So let's plug everything in here. We know that lambda is equal to 2, right? So it's 2. We know that x, small x in our case, is 10. So it's 2 to the power of 10. E to the power of minus lambda, so it's to the minus 2 over 10 factorial, right? Now, what is this? 2 to the 10th, I know from the top of my head, is 1024. I have no idea what e to the minus 2 is, but you can just plug that into a calculator. We can just write it as is because it's just a number. And same with 10 factorial. It's also a number, and I'll just leave it the same. Now, you guys can check me if I'm wrong. Plug this into a calculator, but the probability is equal to about 0.000038. So that means if on average you're eating 2 croissants per day, and all of a sudden, what are the chances that you're going to go all out and eat 10? The chances are minuscule. This is like a once-in-a-lifetime event. So from the day you're born to the day you die, you're eating on average 2 croissants every day. So sometimes you eat 0, sometimes you eat 1, sometimes 4 or 5, which obviously will be a little more. And then only like once in your life you're going to eat 10. This is the probability. This is what, less than 1/1000th of 1%, right? That's pretty crazy, right? So let's take a look at another example. Let's look at, for example, scores in a baseball game, right? So let's say this time that lambda equals 4 runs in a baseball game on average, right? 4 runs. And we want to know, what are the chances that this team, which usually scores 4 runs in a game, will score just 1 run, right? So we're going to write that as what? P of big X equals 1, right? Because we want to know what are the chances of them scoring just 1 while on average they do 4. So let's plug everything in. We have lambda equals 4, right? X equals 1, so we just put the 1 here. E to the minus 4, because minus lambda, the average, and over 1 factorial, which is just 1. And we can rewrite this pretty easy as 4 divided by e to the 4th. And you can also plug this into a calculator to check me if I'm wrong, but the answer is 0.073. What does that mean? That means that this team, on average, if they score 4 runs, that there's only a 7.3 3% chance of them scoring just one run in any given game. All right, guys, now try this problem on your own. I'm gonna ballpark guess that in New York City, about 1,000 babies are born every day, right? So we'll say lambda equals 1,000. Maybe it's more, maybe it's less, but just a ballpark guess. So if we know that the average is 1,000, what are the chances that on any given day there's gonna be a huge burst of babies being born, and we'll have 2,000 babies on that day? So try this problem on your own. See if you get what kind of result you get and if it makes any sense. So this is it. This is the Poisson distribution. It's actually pretty simple. You can start checking things in your daily life today because you know how easy it is. You can just use a simple calculator. I hope you guys like this video. Click like, click subscribe, and stay geekly, my friends.